Now in this example, we need to solve the given inequalities. Now to solve the given inequalities, first we need to start by finding the roots of the given polynomial. So if we start with the first one, if we call f of x the given polynomial, which later on we're going to end up studying its sign to determine where it's positive. Now, over here, similarly to the previous example we did in the other slide, over here we need to determine the possible rational roots of the polynomial in order to be able to find a root of the polynomial. So we start by taking c and a. So c is the constant, which is 8, and a is in fact 1 here, so the only factor of a would be 1. Then c over a is in fact c in this case. So c over a, which is consisting of all the factors of c, since a is equal to 1, is in fact plus or minus 2, plus or minus 1, plus or minus 4, and plus or minus 8. Now as we start trying them, of course when you do try them, you don't have to actually list all of them. It's enough to just give me the one that actually works. So over here, as you start trying them, the first one to work is -1. F of -1 is 0, then x equal to -1 is a root of f of x, or you could just say that x equal to 1 is a factor of f of x. So similarly to the previous slide, over here, in order to start finding the other roots of the polynomial, we need to divide the polynomial by the given factor. So over here we either do long division by x plus 1 or synthetic division by -1. So over here, if you use synthetic division, the corresponding coefficients of the polynomial are 1, -1, -10, and -8, and we're dividing by the root of x plus 1, which is -1. So we drop the first coefficient. 1 times -1 is -1. By adding these, they're -2. -2 times -1 is 2. -10 plus 2 is -8 times -1, that's an 8. And since x equal to -1 is a root, we should end up with a 0 remainder. Then f of x is in fact written as x plus 1 into x squared minus 2x minus 8. Now over here, the question is not really to factorize completely. It's enough to reach the quadratic factor. Now, and of course, in addition to all the zeros of the polynomial. Now over here, x plus 1, its 0 is -1. X squared minus 2x minus 8 is quadratic, so by finding its roots using delta, we determine that 4 or -2 are the zeros of the quadratic factor. Now, once we get here, we have, in order to study the sign of fx, because don't forget that our original inequality consists of the polynomial f of x greater or equal to 0. This is the inequality that's solved, so we need to study the sign of f of x. So fx consists of two factors, which one is quadratic and one is linear. So we set up something that we call a table of signs, which should basically help us study the sign of f of x. Now the first row is in fact a number line for x. So we list all the roots of the polynomial in increasing order. It's the sum, it's a number line. So they couldn't be listed in any order. They have to be in increasing order. So it's -1, -2, -1, and 4. Now for the first row, for x plus 1 has a 0 of -1. And once x equal to -1, f of x is also 0, therefore -1 is also 0 of the polynomial. Similarly, -2 and 4 are zeros of the quadratic factor, and they're also zeros of the polynomial. So, these are for the zeros. Now, regarding the distribution of signs, you remember I've already given you before the rules for the table of signs for linear and quadratic factors. So, over here, if we have a factor in the form ax plus b whose root is negative b over a, then before the root, we set the opposite sign of a, and after the root, we have the same sign as a. And similarly for quadratic factors with two roots. Whenever we have a quadratic factor with two roots, x1 and x2, the rule consists of taking the opposite sign of a between the two roots and the same sign as a outside the two roots. So these are the rules for linear and quadratic factors for the table of signs. So if we go back to our table of signs, for x plus 1, the coefficient of x is 1. It's positive. So all the columns before the root are opposites, which is negative. All of the columns after the root are positive, which are the same sign as a. Now, as for the quadratic factor, the coefficient of x squared is 1. It's positive. So everything between the roots is opposite, and everything outside the roots is the same. So now for the sign of f(x), it's enough to multiply the signs of the corresponding factor. For the first column, we have a negative and a positive. A negative and a positive multiply into a negative. For the second one, two negatives multiply into a positive, then negative with a positive. Now I go back to my given inequality. I want my polynomial to be greater or equal to 0, so I want it to be positive or 0. Then in the row for f of x, we look for the positives and the zeros of the polynomial. Therefore, the solution set of the polynomial is from -2 to -1, including the bounds, because we want the zeros here. We have an or equal union for positive infinity. So this is for our first inequality. Now, as for the second, if you open up a new page here, the second inequality is 2x cubed minus 5x squared minus 6x plus 4 strictly smaller than 0. So, similarly to before, we start by finding the roots of the cubic polynomial, which we would call f of x, for example. So let f of x be 2x cubed minus 5x squared minus 6x plus 4. So, over here, to start finding the roots of the polynomial, we need to start by listing all the possible rational zeros of the polynomial. Now, over here, c is 4 and a is 2. So, c, all the possible factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4. As for a, they're plus or minus 1 and plus or minus 2. Now, c over a, all the possible rational zeros are in fact all the factors of c divided by all the factors of a. So all the factors of c divided by 1, we get the factors as they are, and then all the factors of c divided by 2, which is the second factor of a. Now, 1 divided by 2 is plus or minus half. Now, as you can see here, 2 divided by 2 is 1. So that's the one which I already have in the set, so I do not write it again. And similarly, 4 over 2 is a 2, so I already have it in the set, so I do not write it again. So this is it for c over a. Now, as usual, we start trying them one by one in order to find a root of the polynomial. So over here, we would have f of half equal to 0. So half is basically a root of f of x, or 2x minus 1 is a factor of f of x. So I start by dividing f of x either by 2x minus 1 using log division or by half using synthetic division. So using synthetic division, we list the coefficients of the polynomial. Then 2 times half is 1. Negative 5 plus 1 is a negative 4 times half, that's a negative 2. Plus negative 6, that's a negative 8 times half, that's a negative 4, which adds up with 4 into 0, which is our remainder. Then f of x is x minus half into 2x squared minus 4x minus 8, which, if we fix it up a bit in order to get 2x minus 1 as a factor, we factor out a 2 from the other factor and end up with x squared minus 2x minus 4. Now, by finding the roots of the quadratic factor, we start by finding delta, which is 4 plus 16, which is 20. Then x would be 2 plus or minus square root of 20 over 2, which when we simplify this, we would end up with 1 plus or minus square root of 5. So these are the two roots of the polynomial. In order to study the sign of f of x, we start by setting up a table of signs. So the first factor for f of x is 2x minus 1. The second one is the quadratic, x squared minus 2x minus 4. And finally, we have f of x. Then, for the number line, we start by listing the three roots of the polynomial in ascending order. The first one is 1 minus square root of 5, which is the smallest, then half, then 1 plus square root of 5. Now 2x minus 1 has a root of half, and half is also a root of f of x. Now 1 plus or minus square root of 5 are zeros of the quadratic factor and also zeros of the polynomial. Now we distribute the signs according to the rules for the table of sign for linear and quadratic factors. For the first one, the coefficient of x2 is positive, then before the root that's opposite, after the root, it's the same sign as 2. Now, for the quadratic factor, the coefficient of x squared is 1. It's also positive. So between the roots, everything between the roots is opposite sign as 1, and everything outside the roots is same sign as 1. For f of x, we just multiply the signs in each column. So that's negative, plus, negative, and plus. Now, over here, if we go back to the inequality, the inequality is strictly smaller than. Then they just want the negatives. Now, these are the intervals where f of x is negative. We don't take the zeros here because I do not have an or equal. So, therefore, the solution set of the polynomial, or x belongs to negative infinity, 1 minus square root of 5, union, the intervals are open because we're not taking the zeros here, union half, 1 plus square root of